Thank you everyone for coming. My name is Lars Albertsson. I'm the founder of a small data engineering startup called Skling. And we have a very simple marketing strategy that has worked well so far. We freely share information that we believe is useful for others in the form of presentations, as today, and there's also some links to other presentation and resources on our website. And I will tell you at the very end what we do, and those few seconds that you have to endure is the price that you pay. I hope that you found it fair. I've spent the last 10 years or so of my career on the right side here of the graph, trying to extract value from data in companies that have data to help them get more value in one way or another, as an employee, as a consultant, and now as a startup. And if you have ideas on how to make companies move along those first steps there, please come and inform me, because I find that very difficult when there isn't a sort of a foundation of information in the companies. That's outside our scope. But in many companies have some, if not a complete foundation, lots of data that could be valuable, nevertheless. I was asked to hold two presentations here at the conference. Today, we will look back in time. We will look to see, for those companies that do succeed, coming far out to the right and get more value from data, what are the things that they are doing that differ from the companies that have data but don't succeed as well as in getting out that value. And I don't have the scientific methods to say that there is causality in the things that I present, but at least that there is correlation. So I will present things that these companies that succeed very well and don't succeed so well seem to do differently. I will first start with explaining what does success with data mean. What are the things that we can, where we look at companies, can see whether they are successful or not. What does it mean to be successful versus less successful? You'll hear lots of companies that say we have success with this and that, but if you look at them, those few in Scandinavia and in Europe that are really successful, they do things quite differently, and there's a huge gap in between there in terms of getting value. And then I've sort of taken inspiration by an old book by Stephen Covey, 7 Habits of Highly Effective People, and sort of picked out 7 habits that seem to be common for these companies. I haven't squeezed in the same habits, but you'll see that there's some overlap in occasionally. I will talk a lot about value creation streams, and this goes outside of data. Whenever we humans create value of things, we take something that it has a potential, is like an idea or a piece of data or raw material, and we work with it, and then we create something that is more valuable. I will mention different types of value creation streams. The one that we will look most at is from raw data to sort of valuable data artifacts. In that stream, and in any value creation stream, there are like intermediate artifacts that are produced, like the engine of a car is not useful in itself, but that's an intermediate artifact that is part of a car. And likewise, there are intermediate data artifacts, and we call them data sets, pieces of data that have some kind of intermediate value. And by data set, I approximately mean something that you could store in a table in a database or in a bunch of files. So, for example, the list of all sales transactions from yesterday is one example of a data set. Sometimes they're raw, sometimes they're fine. And if we look at the number of data sets produced by different types of companies, we'll see that there are huge differences. This is not scientific by any means, but I've taken the habit in the last 5-10 years of asking companies what their data sort of value production or data set production looks like. And in most companies, you will see these numbers being in the hundreds or in the thousands per day at mature companies, for banks, telcos, insurance, and so forth, that have mature teams that of like 50, 70 people that in a data warehouse environment that produce data. And you can see that there are several orders of magnitude to the very highly digital companies. The one that in Sweden that produces the most data is Spotify. These numbers are a bit old. They're probably producing on the order of a couple of million of data sets per day nowadays. It's hard to get these values, so you have to puzzle pieces of information together. Google was public with these numbers now 6 years ago, and they're producing a number of billions of data sets per day. And I will show an example later of how similar activities can differ so much. A question in the back. And it's one thing you can deduce is that the cost of producing data sets is kind of different. Like if you're producing 100 from a team, or if you're producing billions, you have to push the cost down in order to get to the billions, which means that you can reach for the things that are higher up in the tree, where there is less value per value creation stream, but nevertheless some value. I spent a bit of time at one of our large banks, and I sat next to a team that were doing what's called master data management, getting a view of all the users in the bank, and those are on the order of millions for Scandinavian banks. They were working in a sort of a fairly traditional way with a proprietary tool from Informatica, if I remember correctly, one of the better tools out on the market. And it was a full-time task for about 5 people doing this. As it turns out, I had the same task as when I was working on Spotify a number of years ago. And that team that I was in, we were 5-ish people, and we had 10 different data sets similar to the master data management for the users, which were called master user. And this is the flow that created master user. It's similar in complexity to the task at the bank, but with 2 orders of magnitude more users. And we had a bunch of other tasks as well. So at some point we did an exercise and counted how much time we spend on different things. So we concluded that producing this data set, which is the business-wise the same thing as the 5-people team were doing on the bank, took about 0.1 of a full-time engineer. So this is an example of doing the same task. Cost can vary a lot. So that's one metric of efficiency. Another metric is the capability to produce value from data. This is from the early days of the COVID pandemic in Sweden. This is from the health authorities and the number of fatalities. And if you look at this graph, there's only one conclusion to draw, right? It's dropping off. The pandemic is now over. We know that didn't happen, but if you present the graph this way, this would be the natural conclusion. The problem here is that there is a delay in data collection, so that you don't have all the data on the right side. And if you don't compensate for it, you will each day, they show this kind of graph, and each day they display the graph where the obvious conclusion was the wrong conclusion. It was pointing down each day. So how should you do this in order to avoid that? Well, you have to take the delay into account and perhaps measure similar things that can be compared, right? The number of fatalities that have been collected during the time of a week or 2 weeks or whatever, so that you give them give the data some time to appear. And if you want really fresh data, well, then you have to look for the older data. You have to discard the things that took more than, for example, 2 days. And then you can come up with these graphs here that are rugged, but they're at least comparable. And if you want even better predictions, you can do forecasting and get the upper graph here, but then you have to look at historical data and sort of fill in the blanks that are missing. But that's quite a difficult task, so that requires more computation and so forth. And of course, the health authorities, analysts, they know these things. They just haven't been able to push the cost of computations down so that they can do this each day on a daily basis. I drive a Volvo, fairly newish one. It's an impressive car. This guy on the right is the CEO of Volvo. His name is Jim Gowan, I think. He has this warm Scottish accent. As he tells you, and this is from an ad, and he tells you that we use state-of-the-art technology with LiDAR sensors and AI software to keep you safe in the car. It sounds like this, like you're watching this episode of Shetland where Douglas Henschel says that if you just ride this car, you will arrive safely and everything will be fine. So Volvo is doing some very impressive things, in particular in relation to safety. The thing on the left here is a functionality that I discovered on the road at 70 kilometers an hour, that the car had this functionality. It's suddenly weird because another car was coming and I wasn't paying attention. And they have so many safety features that this was not in the product marketing, right? I had no idea the car even had this functionality. I drive an XC90, a T8 from 2017, something. So Volvo is really managing to do some complicated data processing in their focus area, right? And I'm impressed by these things. I like the car. I will probably buy a Volvo next time. And Volvo Cars has not paid me to sell this. This is an atonement for what's on the next slide, because this fantastic product is also a pile of missed opportunities to take more advantage of data. A couple of years ago, I started collecting examples of where Swedish companies could have used data to make their products better. And this pile stretches over all the companies that I'm in contact with. It's Volvo here, but it could be ICA or Coop or IKEA or whatever. This is a common factor, that they miss opportunities to create more value from data, except for a couple of companies that I use a lot, for example, Google and Spotify, who are missing from this list. So examples here is that the car has sensors on the windows and on the sunroof, so it knows whether they're open. I can look in the app and see whether they're open. It has a rain sensor, so it knows when to do the wipers. So when the sunroof was open and it started to rain, it could have warned me, hey, maybe you want to go and close that sunroof, but it didn't. So I had to go to the mechanic, and we had to repair the electronics. And as I did that, it was hard to get the radar right, because it had been damaged and had to be replaced. So I asked the mechanic, well, it doesn't seem to do the right thing. Can you get information for Volvo so that you can synchronize it? And no, you'll have to try again and come back. So I went there 3-4 times, but while they were calibrating this radar. So these are 2 examples of things that are not complicated, not nearly as complicated as we saw in the last example. But one, the data hadn't propagated from the source to those that needed it, and/or 2, it was difficult to make computations with it. And there are lots of similar examples involved in other products. What does it look in companies where you have the data available and we don't have any friction? This is a slide from a presentation of the people that made Discover Weekly at Spotify. And they said, we were able to do this not by the company decided that this was a really important thing to do, as probably is the case for all the safety technology involved. Not by the company deciding that this is really important, allocating 50 engineers and make a big effort. We were 3 people. We had an insight from the data that we could access and saw, we can probably do this. We built it in 3 weeks. And the CEO said, I didn't see the beauty at all. I would have killed it. It doesn't work that way, so we just didn't give them any more resources. But they launched anyway. A year after launch, this feature had 40 million active users. It's probably the most successful machine learning feature ever built by a Scandinavian or perhaps European company. And the CEO would have killed it, right? So the data was available, and there was no friction in using it. I bring this up a lot because I'm very proud of this one, because 18 months before they launched, we set out with the explicit goal to democratize access and use of data within Spotify. And this is precisely what we wanted to happen, except that we didn't know that would look like this. So now off to the 7 habits that I've seen. The first one is that data in data successful companies is handled through essentially an industrial process rather than by an artisanal craftsman process where you mostly work with the data by hand. And we've seen this shift from craftsman work to industrial processes in other parts of IT. For example, we used to manage servers by SSHing into them and manually installing all the right things. We're not doing that anymore. We're working, instead of with the thing itself, we're working with the process, the blueprint to create servers in the cloud or in containers and so forth. Likewise, we're doing with QA. We're not so much manually testing things anymore. We have an automated process so that we can test all the time and do continuous delivery and deployment. And the engineering effort that we put in is not into the testing of the things themselves, but into the process of testing. So it's from craftsman work to working with a process. And if we go back to the health authorities example, what they did was a craftsman processing of data. They took the raw data and they created an artifact out of it, this graph, right? And it was once, and every day they would do the same thing essentially by hand. I know because they actually have public source code, so you could see how they were working. What you need to do in order to do the things that I presented earlier by showing different types of graphs and forecasting and so forth is to run the same process in multiple variants where you look back different time windows in time. And in order to do forecasting, you have to look back and extrapolate and fill in the blanks. And that's a difficult process. So you probably have to do several different variants and then evaluate them later. So you also run processes that do the evaluation and present the evaluations of the forecasting to you and so on and so forth. And this, for one business case, is likely to produce hundreds of data sets per day if you have a flow that you really care about. And that's why we see the companies that are succeeding producing hundreds of thousands or millions of data sets per day because all of the important flows like this, they blow up. And this is a requirement in order to get sustainable return on investment from AI technology. You can build a model, you can launch a model, and with luck it works, but probably it won't work over time. You need a whole entourage of measurements in order to sort of keep it running and keep it running well and get sustainable return on investment from machine learning. Once you have a factory, the companies succeeding with factories also have a focus on keeping them lean by reducing waste, parts of the process that delay the feedback latency loop or that include extra toil. There is a technology for identifying waste called value stream mapping, where you identify the different activities into value-adding activities like writing code or debugging or researching or writing tests and so forth, and then non-value-adding, which is everything else. And if you do these exercises, you will find that the vast majority of things that you do are non-value-adding. You're waiting for things, you're coordinating with people and so forth. And there are a number of common sources for waste here. Some of them are sort of fairly easy to see. You might have redundant technology and so forth. And some of them are difficult to handle. For example, when you're following rules that used to be relevant but are no longer relevant. And we'll talk more about this tomorrow because that's the central theme. And in theory, it's easy to sort of remove the waste. And I've seen it work well in companies where you have this culture. Why is this necessary? Spotify has a very strong such culture. And then we have been successful at removing things. But in practice, it's more difficult than it looks, because it turns out that you have many assumptions of what's actually needed to be doing. Number 3 is related, and that is that successful companies tend to be driven by business use cases when they decide to do things, and try to be aligned with teams forming along the value streams. That means that along the value streams, there are few handoffs between different teams, where one team hands things off to another. And also the activities are actually focused on creating value impact. You can't survive only with streamlined teams, so you need to have supporting teams in some cases that run platforms or that do a very specialized thing. But in successful companies, I've seen that the activities of those teams are strictly controlled by the activities on the streamlined team, so that they serve the purposes of the business rather than having their own agendas. I was once in a situation where we had a team like this on the red here. There was one team that was collecting the data, and then they were handing off to the next team that were cleaning the data, and then they were handing off to us, and we built like user models, and we were supposed to hand things off to the next team that were doing ads and so forth. And all of these teams were, of course, in different geographical locations. We worked like that for about a year. We didn't get any business value delivered at all, because there was no feedback loops in place from was this actually useful or not, and so forth. In order to be aligned along the value stream, the teams need to have sufficient competence to do all of the things along that line, right? Which may include scary things like UX, for example, to figure out what you should do in the human interface to measure whether your things are actually working or not, and so forth. The trinity of competences to succeed with data is data engineering, where I include some software engineering and basic automated testing and DevOps and so forth. And then people that are experts in the domain, the domain at hand, and people that care about products and know how to sort of steer products to be valuable. That doesn't necessarily need to be 3 different people, but I've seen that if one of these is missing, things don't go as smoothly as they could. And for teams that focus on generating business value, I find that they focus generally on simple things, because if they are driven by creating actual value rather than building technology, they start rejecting all of those complicated things that seem to be that happen to be trendy, and focus on the valuable things. And it turns out that most of the things that I collected in this list of things that companies can do better have nothing to do with AI or machine learning, and it's usually about being able to count things and being able to propagate data to the right people that can take action. Part of being driven by the use case is what I call being pull-driven. So you have an idea of how to produce value, and then all of your actions upstream are drive towards that value. Whereas it's common to see in companies activities that are push-driven. We need to have this fantastic platform. We should do more AI. We should do so on and so forth. And then there's a much longer path to eventually creating value. The most striking example I have of the difference here is 2 companies who happen to do the same game. Lego did something called Lego Universe. They started back in 2002 planning the plan for 4 years, and then they built the thing for 4 years, and they really wanted to make a fantastic game. They had a good idea. You put things on top of each other and build things with bricks and so forth in this virtual world. And they spent $125 million, like hundreds of people. They had an orchestra playing the music and so forth. At the same time, someone else was doing the same game. They made a prototype that in a week. They threw it out to users and said, what do you like, what you don't like? Instead of planning the perfect game, they asked the users. They happened to make the most successful game ever, right? And that Lego universe thing doesn't exist anymore. Essentially, all of the companies that I've seen being successful have started with heavy centralization in terms of technical centralization with the data solutions. In the early big data days, this was natural because we installed Hadoop clusters. Turns out Hadoop is bloody expensive to administrate, so you only want one of them if you can escape with it. And they also have like crappy security primitives, so everything is readable by everyone, so you get like democratization for free. So this was natural. Now it's more difficult because you have many more solutions and some of them are decentralized. There's a current trend of decentralization, which I perceive as very harmful, because if you decentralize too early, you will not have the homogeneity of processes and technology that is crucial in democratization of data access and the ability to do things with data. It seems to me similar like the microservices trend we had like 5-10 years ago, where everybody was doing microservices with the tiniest little things, and forgot that decentralization is a way of scaling. And the successful companies that I've seen had centralized technical solutions up until they've been producing hundreds of thousands of data sets and have hundreds of people working in this centralized solution and so forth. So until you're there, you probably don't need to decentralize. You can postpone that for a very long time. Why is this centralization so important? It's important for democratization and innovation. If you have a traditional sort of microservice-based environment where all of the data is living out in different silos, if you have an idea, then you need to synchronize with all of the teams. Can we access your data somehow? Can you put us in your backlog and prioritize us? And what are the governance rules? And how do we measure quality of the data and so forth? And this is enough friction to kill most innovation. Whereas the real impact of big data when it came was not the ability to handle web-scale data, because most companies don't have web-scale data. The real impact was a new way of collaboration where the data is put in a central place and you have common processes for handling the data and accessing the data and so forth. In that centralized solution, it's important to architect the ways that you work so that, one, you can share things safely, and two, you handle things gracefully when they fail, because they will fail all the time. There's new technology here that we're using that is fragile, and the complexity of things that we can handle there is typically much higher than the things we handle in our microservices, because we handle data that spans across different parts of the company and different domains in order to do things like fraud detection, recommendations. We want signals from everywhere to do the right things. And it also spans across time. You have both fresh things and very old things. And the way that we architect for failure is to accept that the probability is high, but we focus on bringing down the impact of failures. One key word here is functional architecture. And by functional architecture, I mean not functional programming, but at the architecture level, gluing things together so that they abide by functional principles of immutability and transformations and so forth. I'll do more of that in a minute. If we zoom in on how these data factories look, when we build a factory, we take the data from the sort of traditional database-oriented world, which is primarily object-oriented. You can view each record as an object, and you can mutate them and so forth. into this factory world where we store immutable data in something called the cold pond or the raw store or whatever, where we don't ever change it or touch it. And there's a little asterisk here, which is privacy regulations. And we do have solutions for that, but they are complicated enough so that I want to scope them out of the presentation. From that raw data, we apply transformation steps, and we don't change the data. Instead, we produce new data sets that are functions of the raw data and the code that we apply. And then eventually, on this side, we have produced data artifacts of value. We separate this core of the factory here, which is offline, from the online systems that we take data from and that we deliver data to. Here in the online world, if we do something wrong, it's expensive, users get affected, people are unhappy. Here, we can tolerate failure. If something goes wrong here, we still have some old data here that we can use. So nobody is immediately affected, and therefore we can tolerate a higher probability of failure. But it's important that we do this separation properly. This is an example of different paradigms to handle data, from the sort of very object-oriented REST concept here to the left, where you really expose, like here's an API, but there's really objects, you look at them, you can mutate them and so forth, to the very right here that abides by functional principles, where everything is immutable, you only produce new things by transforming, never mutating, and so forth. And then there's a scale in between. And those that are successful lean towards that direction, because that's more forgiving in terms of failures that might happen. So this forgiving environment enables us to innovate fast. If we have a new idea, we can build a separate pipeline to sort of produce data sets in a different way. And in this offline environment, we're not causing any operational trouble as we would have if we did it in the online environment. And we can run as many pipelines as we want in parallel and compare the results and say, oh, this new one, is it better? Is it not? It seems to be better. Let's try the output of that one instead. And if it doesn't work, we'll revert to the old one. So this is how people are able to experiment and innovate quickly with minimal operational risk. This also removes the need for traditional ways to mitigate operational risk, for example, by having a separate development environment and a staging environment and a test environment and a production environment and so forth. We run everything in production, and we use this concept called dark pipelines to sort of mitigate the risk of something bad going out. These types of environments are more forgiving to failures that might happen. And I'm going to quickly go through an example here of a failure scenario where we output bad code and it produces the wrong data. If we have a microservice environment, this instantly spreads everywhere. And there's no patterns to recover from this scenario. If this happens in your environment, you have a very bad day. So if we look instead in a batch environment, is sort of a data lake environment. We have a pipeline that produces the wrong data, but we're storing some old data sets, for example, recommendation indexes or fraud detection indexes. So once we notice that something has gone wrong, we can switch back to those older data sets that we have produced. We can fix the bug, and we sort of bump the version of the pipeline so it produces a whole new pipeline. And then once it has backfilled, we can switch to the new one. And this cuts down the operational toil significantly, right? The data only flows in one direction, so we know where the bad data is. We have a batch system where we have explicitly defined the dependencies between the data sets, so we know which data sets are bad and which aren't, and so forth. So this is how we could do, for example, master data management with just a fraction of a full-time engineer. And if you go to stream processing, data only flows in one direction, but the operations, in case something goes wrong, is significantly more different, because in every stream processing application, unless you are prepared to reprocess everything from the dawn of time, which may be years of data, you have state that you need to relate to. And so you have to sort of merge in this state at just the right moment if you want to restart the stream. This is the blog post from Confluent, who are thought leaders in streaming, on how to do what I just described in a slide. And it only works in a small subset of cases. Don't let anyone fool you that stream processing is just the same as batch, but quicker. There's a significant price in operations that you're paying. So the companies that have been successful have tackled the data value extraction as a software engineering problem. I've seen other attempts to other angles where you can tackle it as a strategy or as data science and so forth. The ones that seem to be successful view it as an engineering problem. And by engineering, I'm not necessarily saying building technology. You can buy technology, but building the processes and the ways of working, and building tooling that supports the ways that you have decided that people should work. And a general principle that seems to have been successful is to use more carrots than whips in doing this. So you build tools so that it's more convenient for people to work in the ways that you want them to work to get the homogeneous way of working. And you call this the golden path. This is how we want. But the doors are not closed. So if you have a good reason for doing something else, you can do that. And by the way, let's look at what your reasons are, and maybe we can innovate on the processes together. In order to maintain speed, quality assurance and testing is a fundament which is absolutely necessary in order to sort of achieve the levels of efficiency I've mentioned. Something that we'll go into more tomorrow is there's a trend now of low-code and no-code tools, in particular for example for visualization with Looker and Tableau and so forth. And you can use them, and they are popular for a reason, but you can never achieve the same level of efficiency in my experience. So this is a quotation that you might see from people using low-code tools, that you should have such an environment that you are able to build every dashboard in 2 days, right? But dashboards is just a web application. If we write them in code, as we do all of the other web applications, we know how to test that since like 15 years back. So we know how to do continuous deployment of web applications. This is a solved problem. The last little piece I want to give to you is what I call the Unix philosophy. And this affects what kind of tools and components that you bring in. You can sort of rely on the vendor to sort of serve you everything, or you can bring in tools that do lots of things, in which cases you might have some overlapping, or you can take tools that do only a few things well, but where you have to work and sort of build the mortar that holds them together. And this might be more of a correlation than causation, but these are the environments that I've seen be more successful. These are very popular because people tend to select tools as how many features do they have, and then they pick the one with the most features. So if you use components with a small scope that do few things, it turns out that it's much easier to reverse and change your decisions that you don't like. This is an example also from the way back in Spotify when we did this support for continuous deployment. We had realized that we needed a safe, self-contained deployment image, and we evaluated Docker, but it was so unstable at the time that it wasn't useful, so we built a custom thing where we packaged everything into a jar and then some script that unpackaged it, and here's a cron job, let's install that and so forth. It was only a few hundred lines of code, and it did the job. But more importantly, it only did that job. So when Docker became stable, it was really easy to throw that out and say, okay, now we're building container images. And it wasn't tied to debug, how we debug things or how we log things or how we develop things and so forth. It only did that little thing. And then we could continue. Once Kubernetes became available, we could do the deployment there instead without changing anything else. So this is an example of how the Unix philosophy helps you to move and innovate faster. This is a sequel to the 7th Habit book called The 8th Habit, which is about finding your own voice and helping others to find their voices. There are many who will tell you what the needs that you have are because they want to sell you something and so forth. Be driven by your own use cases. That's how you create real value. I find that this, I'm engaged in this, and it turns out to be really, really difficult to help companies do this. And as a conclusion, I've formed a company where we're trying sort of a new mode of collaboration because I'm convinced that the current ones that we have, for those of us that have been in data successful companies and to get that knowledge out, don't work particularly well. So what we're doing is sort of data processing as a service in collaboration with our clients. So it's similar to consultants in the sense that we're doing custom solutions, but we run and host and develop them and so forth. Will it work? We've seen it work in terms of in some cases not so well. So it's a long journey to sort of figure out. The reason that I'm doing this is that I feel as tech nerds, we have a responsibility. We have a massive impact on society, much more than other people in the world. And I want to use that to sort of have a good impact on the world and leave a better world for my kids. So I'm seeking to help the multitude of excellent companies that we have in Scandinavia that have great values, so that we don't end up having a Facebook kitchen appliances and Amazon vacuum cleaners and so forth. That is my choice, and I urge you, if to agree with me or not, but at least make an active choice on what you do with your talent and the power that you've been given. Do nothing if you want to, but make it an active choice to do so, and sell it if you want to, or try to do something good. That's what I had to say. Thank you, everyone.